Quiz 4.6 through 4.9 is due tomorrow at 1 p.m. It's about 9 or 10 questions. It's not very long. It shouldn't take more than 10 minutes. Thursday, your soil lab, your virtual earthquake, and your ring of fire are all due on Thursday. Hopefully we'll have a few minutes at the end of class to go over and have any questions. If you have any trouble with the ring of fire, I think I gave that to y'all early since y'all were out on Friday. So we're going to staple that together and turn all that in tomorrow. And then Friday then is your test on Unit 4 on Earth's resources and systems. And then we'll start Unit 5 on Monday on basically agriculture, sustainability, not using more than you need to. Today, we're going to talk about solar radiation and the Earth's seasons. So, seasons. What are the 4 seasons? Go, Sarah.
Fall, winter, spring, and summer.
Wrong. It's autumn. No. All right. So, if you were living at the equator, I don't know, let's say maybe like in a country close to Venezuela, what would your seasons be there, Andrea? Rainy and dry. What about temperature-wise?
Day and night.
Hot and hot?
Oh, yeah.
Okay. Tell us about the rainy and dry season. Now, I went to Costa Rica a few times in March, and we went during the dry season, and that meant it rained like every 3 days instead of every day. Is that about how it is in Venezuela?
No, it's not. Like if it's dry season, it won't rain for like a while. And then when it's like rainy season, it rains like pretty often, but it's almost like daily or at least every other day, but it doesn't rain like for long periods of time. So it's just like a while and then it stops. Yeah.
So y'all had a longer dry season than than what you would say like a tropical rainforest would have.
No, not really. It's just like, I mean, they're equally as long. It's just like when it's dry, it's more dry than other dry season, than what you would consider a dry season. I don't know.
I'm going to have to look that data. All right, so let's see. Seasonal data. What causes the seasons, Isabella? We're on page 95 in the book. The what?
How the Earth tilts.
Well, how much is the Earth tilted?
23.5 degrees.
Yummy. So there's a tilt of 23.5 degrees. How far are we from the sun, Carly? You might know.
That clock is going to drive me nuts.
That's why I put it there. We are 93 million miles away from the sun. 93 million. The diameter of the Earth is about 8,000 miles, okay, across. So it's not very much considered. Some people have this idea that the seasons are caused by the distance away from the sun, and that's not the case. It's just a tilt of the Earth. The seasons in the southern hemisphere are what, Simona? Sarah? Compared to ours. Seasons in the southern hemisphere are what compared to ours? Mm-hmm. So if you were in Australia right now, what would it be?
Oh, it's opposite.
Okay.
It's summer. Or no, spring.
It would be springtime since we're in fall. Good. So they are the opposite from us because they're getting different angles from the sun than we are based on how the Earth is tilted toward or away from the sun. And we'll do stand up and do some examples here in a minute once we go off cam. But on page 95 there, it shows that. Latitude. What is... Okay, everybody get out your phones real quick. And open up the compass on your phone if you've got one. Most iPhones have them. I don't know about Android. Open up your compass. Okay. Important things to know. You got one?
I don't got one.
Do you have an Android?
No, I have an iPhone. It just doesn't.
I don't have one. I think I deleted it.
Yeah, probably.
Save space.
I mean, like the compass probably takes up like nothing. So much more room on my Snapchat. Oh yeah, 3 more snaps and 3 more streaks if I just get rid of that compass. Maybe you can look at Simona's there, Victoria and Carly. I don't know what you can do. Okay, Isabella, what latitude are we at? What is latitude? Does anyone know what latitude is? Yes, ma'am.
It's it's like one of the ways to measure the axes on the like coordinate plane of the Earth. To find pinpoint.
Yes, it's how many degrees north or south of the equator you are.
Yeah, that.
I think that's what you're going for in the most complicated way possible. So, the amount north or south of the equator we are. And our location here, how far north of the equator are we? Jacayla, you got it pulled up?
No, I don't think I have one.
God bless America.
33.7.
33 degrees north. Good. We're a little over 33 degrees north here. Now, the equator is what latitude? What degree? 0. The North Pole is what latitude?
0.
The North Pole?
The North Pole would be.
The North Pole is the same as the equator?
No.
What? 180. Ah,
360.
It's 360 degrees around the globe, yes, in a circle. I'm glad we've learned something. But you're only looking at, imagine you're looking at like half the globe. So that would be how much? You're going to divide the globe up because you're only going to look at half of it when you're going from equator to North Pole and South Pole, right? So 1/2 of the globe would be how many degrees? Half of 360, 180. And you divide that in half because the equator is 0 going to the North and the South Pole. So the North Pole should be 90. The North Pole is 90 degrees north and the South Pole is 90 degrees south. And so 90 plus 90 and then the other half of the globe, there's your 360. Lord have mercy, I don't know what your math class looks like. But I'm gonna have a talk with the math teacher. Okay, let's go back to circles and degrees. So we're at 33 degrees north, so that should give you some idea. Where are the tropics located? Does anybody know the degrees for those? I'll give you a hint. It has to do with the tilt of the earth. 23.5 north, 23.5 south. Those are your Tropic of Cancer and Tropic of Capricorn that you see on page 95 right there. Those are the zones, but in between those two latitudes are where the tropics are located. Okay, so we're just above that. If you go down to Key West, you're, I think, about 25 degrees. So that's what we call the subtropics. So it's pretty close. Hawaii would be the only United State that's in, or part of the United States that's in the tropics. So that is latitude. Latitude, what impact does it have on the solar radiation? The most solar radiation is at the what? Equator. It says poles. Mark that out if that's, there was a typo on the paper. Most solar radiation is at the equator and decreases toward the poles. The higher you get in latitude, the less solar radiation there is. Good. The angle of the rays' suns determine the amount of solar intensity. Now, you go to the beach, see all these people laying out there trying to get skin cancer. You know what I'm talking about, Sarah?
Yeah.
What time of day do they go out there and lay and try to get all that skin cancer? I mean suntan.
The mornings.
The morning?
Like middle of the day.
Middle of the day, okay. Because what time, if you were trying to avoid the skin cancer, would you not want to be out there, or would you want to apply a lot of sunscreen or wear a rash guard? Middle of the day. Between about 10 to 3 are the most intense rays coming from the sun, because the sun's rays are?
Radiation.
They're like right over you, right? So they're right over you, they're beaming down on you, they're hitting you hard, and that's where the sun's rays are the greatest. Now, if you wanted to go out and have less exposure to radiation, when would you go?
The morning.
Mornings or
9.
afternoons? Yeah, of course the night. Yeah, thanks a lot. But the mornings and afternoons you would have less radiation for sure. All right, so the more solar intensity, the more the sun's coming directly down on you, the more radiation there is. The infrared radiation, which heats up the earth, and then UV radiation, which also comes down upon us. We talked a little bit about UVB and UVC rays in the ozone layer protecting us, but some of that stuff still sneaks through, and you got to be careful because skin cancer is bad. We'll talk more about that. Let's see. When is the longest day of the year? Antonise? Antonise? Longest day of the year? You know what it is? You got a guess? Andrea? What day is that? Summer solstice is what she said. June when?
June 10th.
It's usually 21st, 22nd. I don't know about that. So usually 21st, 22nd of June, that is the summer solstice. And then the shortest day of the year is when?
December solstice.
December solstice, which is
December
21st, 22nd, somewhere in there. So that's the shortest day of the year. Also, the summer solstice is when what starts?
Summer.
Technically the first day of summer, and then the winter solstice starts, or indicates the first day of winter, although usually it's getting colder before then, so.
Summer solstice is I thought it was midsummer.
It is the longest day of the year, usually June 21st or 2nd.
Yeah, but I didn't think it marked the beginning of summer, I thought it marked midsummer.
I mean, it's kind of weird because you would think it would split summer since it's the longest day, right? But typically, it typically is warmer in July and August because there's kind of a buildup of heat up to that point, and it builds up and builds up, so it takes a while as those days start getting shorter after June 21st before it starts to cool down again, usually over in September. I know what you're saying, like it would make sense if it actually split summer, but that's not, I don't know who decided that was the first day of summer, but that's how they go about it. They didn't ask me, Andrea.
Because in a lot of countries, they call summer solstice midsummer instead of summer solstice.
Those crazy Americans, who knows what they're thinking? Maybe you should look that up for extra credit. Who decides when summer is? Summertime. I mean, I like to think of summer between like Memorial Day and Labor Day. I mean, that seems like a better split probably. Those are typically the hottest months of the year.
I just think about it in May and August. It's cool.
Okay then. Least during the shortest day of the year. Talking about winter. Okay, so we have the least amount of sunshine. Now, so at Christmas time for us, what's it like in South Africa, Carly? Is it Christmas time for them?
No.
Well, it is if they celebrate Christmas. What about temperature-wise? Yeah, Aunt Denise? Yeah, pop it like it's hot, am I right? So, edit that out. So, it is probably hot there because it's cool here. They're getting more solar radiation. I am recording this, sorry. Where were we going with that? I don't know. Okay, let's move on. Earth's geography and climate. Okay, let's turn over to page 88 in your book, and on your phones, open up. Before we leave the compass, let's do a couple things here that you need to know. I don't know if you know this, but on your phone's compass here, some of y'all need to reload this because you got serious problems. I'm glad you got your life together. I want you guys to point.
Teachers, please excuse this interruption. This is an on-call. If Tyler Coleman is in the room, please report to the office. Tyler Coleman.
No comment there. Okay, so you guys point to where north is. Are you looking at your compass?
That way.
For the love of God. Yes.
That way.
You pointed toward the back of the room. Okay, point to where the sun comes up.
Wait, I just got disoriented.
East.
Okay, thank you. Only one person swinging their arm around wildly. So, sun's coming up over here in the east, and it's setting over there in the west. Now, when we're talking about solar radiation, in the summertime, I want you to use your finger. If that's where the sun comes up, then how does it track through the sky? Which way does it go? Okay, pretty good. So it goes from there, roughly the skeleton, about midsummer, and it goes straight overhead or maybe a little bit to the north, and it's going to come out over here. So we're getting these rays of sunshine that are coming like directly down on us, and hence the amount of heat because of that radiation in the summertime. Now in the wintertime, you get over closer to December, where's the sun going to come up? Still going to come up the same spot over here by the skeleton?
Yeah.
No, not.
Probably going to be a little bit over this way, over toward the sink. Okay, because it's tilted away from the earth a little bit. And so what happens is it's coming up in a little bit different spot, and it's not gonna track the same. If the sun in the wintertime, it's gonna come up and it's gonna follow just above the wall back there, and then it's gonna come down over here, probably just on that side of the sink. Okay, so it's at an off angle, a lot lower on this horizon. Okay, because we're tilted away from the sun, and we're not getting as much direct rays of sunshine. Okay, does that make sense? That's why in the wintertime, no matter how much you lay out there by the beach and hoping for that glorious suntan, it just never happens.
But it's gonna take a while.
Well, it would take a while, yeah. The UV radiation's not that great. All right, so open up your weather app on your phone. Hopefully you hadn't deleted this one either. All right, so weather and climate. You have no idea what's going on in life. All right, what's the difference between weather and climate, Sarah?
Weather is the temperature outside, and climate is like the average of your area or something.
That's very good. So weather is the weather is the daily conditions, what's happening outside right now, atmospheric conditions, and then your climate is the average of those conditions over a long period of time.
Oh my god, I actually got that right.
Oh my goodness. Yes. So we've been keeping records. I say somebody's been keeping records for about 120 years here in Alabama. And you can go on the weather.com and it will show you like what the average high and low for today is supposed to be, because we have that data. Now, what is the temperature outside right now?
77.
77. What's the humidity?
93%.
What else is a function of weather? We got wind out there. What's the wind?
6 miles per hour.
Out of the southeast, and the barometric pressure is 29.88. That's went down a little bit since this morning. I think it's 29.96 since the last class. Riddle me this: the barometric pressure. When it goes down, is it going to be stormier or sunnier? Stormier. Good. So lower pressure usually indicates storms coming. If I were y'all, I might get on here and check your pressure before you go to bed, just see what it is, see if it's significantly different. There is literally a hurricane going to come through here tonight, and it is going to be rough. There are supposed to be high winds throughout the night, and if you live somewhere where there's a bunch of pine trees or in a mobile home or where a bunch of trees are around you and you're worried about the structure you're in, you may want to consider going somewhere safer, maybe somewhere if you know somebody's got a basement or something. At least that was the recommendation from James Spann this morning, because winds are supposed to be anywhere from about 30 to 50 miles an hour and could be up to 60, 70 mile an hour gust at times. The storm that's coming through is going to hit Louisiana tonight about 6 or 7, and then it's going to be out of the state by the morning in about 6 or 7. So that thing is going to just truck through Alabama wide open, and Mississippi and Alabama, and it's not going to have time to kind of break down and slow down and dissipate. It's going to be going through, and it's still going to be tight and spinning, and there's going to be a lot of wind with that. So you guys need to be careful about that, okay? The UV index, what is that?
How much light rays are
How much UV radiation? Yeah, so what is it outside?
2
2. In the summertime, when it's hot and sunny, it's usually close to like 10. Okay? So 2 is not a whole lot. It's pretty cloudy outside. We'd expect not to worry too much about sun getting to you now outside right now. Okay, what else? So weather and climate, we've got those. Climate conditions over longer periods of time. Both of those are affected by what?
The sun.
The amount of sun's radiation. Can they be affected by humans?
Yes.
How?
Well, human carbon emissions can affect how, like, our ozone layer holds in heat within the trees. And,
Climate change.
yeah, and greenhouse gases, greenhouse gases that,
Greenhouse gases, okay, so that could be a long-term impact that we've had from excessive CO2 output on temperature. I'll give you another one that's a little bit easier to see on small scale, because a lot of people have trouble understanding like greenhouse gas emissions causing global climate change, which is maybe like 1 or 2 degrees, when we see such temperature fluctuations from day to day. In the summertime, if you live around here, and you live, let's say you live or you have some friends that live out in the country where it's shady and there's still a bunch of trees, and you drive into the city in the middle of the day, what are you going to notice that's different? Like you drive into town by the university.
temperatures,
Why is the temperature different?
because the trees, like, cause more shade in the area, so the temperature is just generally cool, because the sun's not getting down, whereas the city, it doesn't have, like, the trees guarding it, although it could have buildings and such, it doesn't do the same effect to it.
What does the city have that's going to make it hotter?
Windows, like,
It could have factories, it could have.
What?
Asphalt.
Asphalt, concrete. Most of those buildings that are any kind of like asphalt or concrete material, that's going to absorb heat, right? You throw an egg out there in the summertime and cook that joker. So that's going to absorb heat and it's going to hold it in. And I would suspect if you, maybe next summer you try this out, if you're out at a friend's house, you live out in the country somewhere, look at the temperature if you've got one on your car, and then look at it when you get in the city. What are you laughing about? And then see what a difference there is in temperature. What's so funny?
I said windows and you looked at me funny.
I wasn't quite sure how windows heated up the city, but
I mean, they're reflective, so they reflect on their surfaces and make it hotter. You know how you use a magnifying glass to like heat up an ant?
that's not the same thing. We should stop while we're ahead. I'm talking to you. Okay, so weather and climate long term can be affected by humans. This irritates me, and some people in my family have this belief that humans can have no impact on the earth. I mean, I feel like they think we could cut down every tree on the face of the earth and burn the whole thing down, and we could have no impact on our climate or things that are going on the earth. And I think that's probably foolish to feel that way. We've cut down a large portion of trees on earth. We've put down a lot of asphalt and concrete, and you can definitely change. You've probably seen this, maybe, I don't know how old you were in Venezuela driving around or how much is deforested, but when we were in Ecuador, like we would go through areas that had like large clear cuts, and we would get out and look for stuff, and the temperature would be significantly hotter and not as humid because there's not anything there to hold the moisture. And then when we would drive a couple miles down the road and we'd get in an area that's forested, like deep, heavy forested in the rainforest, then it would be, the temperature would be cooler, even though it's still hot and muggy, but it'd be cooler and more humid because of the trees. So you can have large clear-cut areas and see the change in climate. And if you do that over a big enough area, you can have a big change. Would you say that's true?
I don't know, I lived in the city,
Never mind. It's okay. City folks. What else? Sun's energy. Sun's energy is affected by, is going to have an impact on weather and climate. What is geography now that we're talking about stuff? Let's see. Who remembers?
locations of things.
Yeah, location. So location is going to determine these based on your latitude and also elevation. Here's a good question. If I flew to the equator in a plane, which I've done before, or close to it. We landed in Ecuador in Quito, which is the capital city, close to the equator. Is there anywhere along the equator that I could land that it would be cold? Or is it going to be like summertime or warm all the time?
Warm all the time.
Warm. No, I got off the plane in Ecuador and it's cold as a tater. Why?
Altitude.
Altitude. So your elevation or height above sea level or altitude is going to impact also the temperature, as well as latitude. I think Quito is roughly 10 to 12,000 feet in elevation, which is really high up. And so it's much cooler even though it's close to the equator. That's part of that Andes mountain range that runs through there. So anyway, there are a variety of geographic and geologic features that can affect weather and climate. Geographic factors, mountains, ocean temperatures, just like what I said. Let's look on page 98. On page 98, mountains. Okay, this happens all over the world. I've seen this in Ecuador, I've seen it in Australia, I've seen it out west, where you have mountains that essentially are blocking and redirecting moisture, okay? So if you look down the next thing, it says rain shadow effect, draw, describe, and give example. We don't have time for Google Maps today, but let's look on page 98, 414. Read that for us, Jacayla.
Rain shadows occur when humid winds blowing inland from the ocean meets a mountain range. On the windward side of the mountain, air rises and cools, and large amounts of water vapor condense to form clouds and precipitation. On the leeward side of the mountain, cold, dry air
Descends, yeah, and warms. Okay, so basically what's happening here is you have an ocean or a big body of water. There's winds that are coming off of it that have a lot of moisture, and they're headed inland. And if they hit a mountain range, those clouds that are getting pushed inland, the moisture in the air as it hits the mountain range, where's it going to go? Remember, the winds are kind of continually pushing it this way. So if you hit a mountain range, where are you going to have to go? You're going to have to go back the other way if the winds are pushing you that way?
Or up.
Okay, you go up. What happens when you go up? The clouds go up. I drew this. It's fantastic. Clouds hit the mountain range. They go up. When they go up, what happens to the clouds? What happens to the air temperature?
Gets colder.
When you go up in altitude, it gets colder. When air gets colder, what happens to it?
It rises.
What?
Wait, no, it's six.
What does just the particles do? Condenses. Good. They get colder, they closer together, and then that's where you have precipitation. So those clouds move up, those particles condense together, and that's where you have rain and snow, and it rains and snows on one side of the mountain. And that air continually is still coming in, so then that air gets pushed over, but by the time it gets pushed over, what does it not have? Oxygen was not the correct answer. Doesn't have much water vapor left, right? It all rained out on this other side of the mountain. So this side of the mountain over here, what's it like? Dry. It's arid. Okay, that's where you find a lot of deserts. So this happens out west in the Rockies, the Sierra Nevadas that are close to California. We were in Australia. There was this tropical rainforest that was next to the Great Barrier Reef on the ocean, and then you drive over a mountain about 10 miles inland, and everything is super dry. Because the mountains are blocking most of that moisture from making its way over to the other side. When we were in Ecuador, the Andes Mountains, once you go over the Andes Mountains into away from the ocean, I guess that'd be to the east, a lot of that area was just like completely dry. So this basically just has a blocking effect for the moisture. All the moisture comes down on one side, you have a lot of rainforest and vegetation and growth, and on the other side, it's typically very dry. Okay? Any questions? Yummy. What else we got? Oh, one other thing I want y'all to add on there, lake effect snow. Lake effect snow. Now, we don't have this around here because we don't have very big lakes. Has anybody ever been to a Great Lake? Great Lake, Great Lake, Great Lake. Okay, y'all know the Great Lakes? You have. Which ones you go to?
I don't remember what it's called.
It's okay. What did it look like? Do you remember?
It looked like a lake.
Those memories don't help us out. Okay, so this summer I went to Lake Huron. I helped my brother deliver some stuff up north, anyways, and we stopped by the shores of Lake Huron, which is just above, beside Detroit. And you go out there, and there's waves that are coming in, and you look out, and you can see no land. So it's basically like an ocean with fresh water. Okay, so it's very large. And in the wintertime, what will happen is you have a lot of these storm systems, these cool weather fronts, they come in, and then when they go over the lake, they pick up a lot of moisture because this thing's like almost like an ocean here. It's so huge you can't even see across it. Picks up moisture, and then on the other side, it will snow out. That moisture that it picked up will develop, and it'll snow on the other side. And so you wind up with this huge amount of snow on one side of the lake and not really hardly any on the other. But usually this only occurs where you have like very large lakes, where it can pick up a large amount of moisture when a storm front or some type of cool front comes through. Okay, but that can be a geographic feature that can affect weather and climate. Okay, any other questions?